and go live. Alright, says we're live, so let's hope we're live. Good evening, everybody. Welcome to this wonderful Friday. I hope the weather is going to play nice because we had lightning and thunder outside about an hour ago, but it looks like it's passed. So, yeah, hopefully that stays all clean and cleared up, or it might get very noisy at some point. And maybe even a bit dangerous if the lightning comes close. But I think we have passed the worst. My compile is ready, so let's go and hope that we still have a working 3.2.4. Always a bit risky pulling all the latest changes, although for 3.2.4 it should be pretty safe. So it should all be good. So there we go. There's our game. Let's put that over there. I hope everybody's doing good on this Friday. It's been a busy week. Not too much to tell about the week, other than that, I don't know if I showed it off last week, but I have an Android phone. So yeah, one of the things that I have been looking into this week is some Android stuff, which is a lot of fun. Also very frustrating, I have to say. But we made some good progress, so we're not there yet. I still have Godot 4 starting up on my phone and bringing up the Godot screen and then crashing halfway through the load. We solved a whole bunch of crashes. One of the things that was really interesting was something that was introduced not that long ago, where it accidentally was starting an OpenGL context instead of a Vulkan context, and of course that doesn't really work very well. So that was a very simple fix, but it took a couple of hours to find. A bunch of other small fixes and checks and enhancements, and right now it is failing at a point that I'm not completely sure where it's going wrong. But I've been working together with some of the Android guys and with Fredia, who is one of our lead Android maintainers, in actually setting things up better when you look and when you use Android Studio and are able to push out a Godot game directly from Android Studio and then actually step through the source code, which is really nice. That was always possible, but it was a bit of a hassle. And me not being someone who's had a ton of experience on Android, something that I still needed to figure out how that all works. So that was really good. That needs to be continued next week. Unfortunately, time zones are really hurting at the moment. Basically, when I start my day is just about where these guys are stopping their day. So I have about a 1 to 2 hour window each morning to actually communicate with these guys and move that forward. So that's something that I've mostly been doing in the morning. And then the rest of the day, I have been trying to figure out how this beautiful Vulkan renderer works that John made. So I've been doing a lot of dissecting of code and trying to figure out how everything is put together. I started work on a second version of the renderer. So basically, what we're doing is when we have the current Vulkan renderer that we wrote, which is quote unquote the high-end renderer that we made. There's a whole bunch of parts in there that I spent the first month that I worked officially for Godot sort of extracting and putting into separate classes so they become more reusable. And now the plan is to have to still have the core of that exactly the way that it is right now, but have a second implementation sitting next to the high-end implementation, which is purely targeted at mobile. And the reason... Hi, Rodzilla, how you going? Hi, Deco. The reason why we're going down that path is, for instance, when we're looking at the high-end renderer, one of the really, really cool features that John built... Why am I getting... What are you? That was really old. Interesting. One of the things, for instance, that Jean built in, which is really, really cool, which I'm very impressed with. I knew about the technique. I had never implemented it myself before. I have implemented a simpler version of it. It's called a forward clustered renderer. So when we're looking at Godot 3, which is a more traditional forward renderer, basically what that means is throughout the years, when you're looking at different rendering techniques, there's been like two competing main approaches in doing rendering. One is the forward rendering technique, and the other is what is called deferred rendering. And of course, there was a hi Stefan, hi Ezekiel, hi Declan. So when we're looking at deferred renderer, that was the de facto way that most games were being built since the late 90s and all through the early 2000s, because it allowed you to do a lot more things efficiently up to a certain point. So just to give a very brief idea about how this works, should I explain forward rendering first? Is it easier? No, let's explain deferred rendering first. So when we're looking at an image on screen like this, and actually I'm going to go and run my little game because it's actually a good thing to sort of show, you know, in a running game. We have a bunch of lights here. We have some characters in here. And basically when you look at a scene like this, it's actually a composite of a number of different things. Basically, we have the scene lit by ambient light, which in early games is just a fixed light color. Now in newer games, and actually in our game here, it is exactly that. We're only using, you know, plain old-fashioned ambient light. But now with the newer renderings, using things like GI Probe, we have indirect ambient light. So light of a candle here reflecting off of surfaces, and you would get light leaking into darker spaces as light reflects off of walls and that sort of thing. So that's but that's one type of light. The next light that everybody is of course aware of, which doesn't apply to my dungeon game, is when you have a direct light shining on a sun or anything like that. And then obviously we have any number of spot / omni lights in our scene that are all lighting our scene. Now, when we're looking at a forward renderer, actually I'm going to start with explaining a forward renderer because it makes it a little bit easier. What we're basically doing is we're just rendering a scene. I do not want that coming up. Go away. Boom. I am in my stream. In a forward renderer, what we're doing is when we're rendering, like say our mage here, our character, every triangle is just rendered. Boom. So we have, you know, let's say that this whole hat was one triangle instead of, you know, a whole bunch of polygons. You know, triangle of 3 points. It would draw that triangle. The rasterizer would be, you know, going from the 3 points, figuring out which lines it needs to draw, and then it goes through all the lines and it draws every pixel. And for every pixel that we draw, we call the fragment shader. The fragment shader then calculates the color of that pixel, and then it draws the pixel. That's basically all that rendering does in a really simplified form, right? And in a forward renderer, we're doing everything in that fragment stage. So when we are calculating the color of that part of our hat, we are first of all figuring out what material that is. Then we find out that material has a purple color. We should find out how much the reflectiveness is, etc., etc. Then we look at our ambient light. We see, you know, how much does the ambient light contribute to actually making that color visible. Then we look at our directional light. Then we go through every light in the scene to see how much each light in the scene affects that pixel. And then we figure out what the color of the pixel is, and we draw the pixel. Now, if you just have a direct light and that's it, forward rendering works perfect. And that's why it was always used in, you know, for years and years and years and years. But then as scenes get more complex and you start getting more lights in a scene, all of a sudden you have to calculate more and more light values that is potentially illuminating that one pixel. And then obviously there are all sorts of ways to limit that, and that's all, you know, again, Godot 3 works this way. It has a standard forward renderer here. You have ways to optimize where you can say, well, that pixel or this hat actually, because it does it per object, which of these lights actually potentially affect this hat? You know, a light way over here will never light up the hat, so we don't have to, you know, figure out if that light is important. But all these lights here, definitely not, and probably this one as well, because we don't know at this point in time that there's actually a wall in between, because that's a shadow map that's going to block that light. So we don't actually know that that light is totally not affecting this pixel. So all these 4 lights will be affecting that pixel, and we are rendering through or we're looping through those 4 lights to get that pixel value. The more lights you have, the more a forward renderer starts to struggle. That is where forward renderers start to show its Achilles heel. That's where a forward renderer is not very good. So everybody went to this thing called deferred rendering. So for those who want to know a little bit of what deferred rendering does, even though it's a technique that's sort of fallen out of favor, deferred rendering was an idea where they say, well, you know what? Why, instead of going through all the calculations in one fragment shader, why don't we actually figure enough out about what's on screen first, and then we process our lights one by one, and we just, you know, do the calculations for that light. So what you now get is we are rendering this scene first without even thinking about lights. And the scene is rendered, but it's not rendered to one image. It's actually rendered to 4 images. One image gets the unlit color. So if you would see this screen in that image, this would be like as if the ambient light is 100% turned up. Every color would be the color of the texture, unlit, unshaded. So that's the first texture that we get. The second texture is that we store all the normal values of those pixels. So we have basically a screen-wide normal map. The third texture contains things like your specular values, your metallic values, that sort of thing, which allows us to take that into account. And the fourth one is position, is an encoded position, so that we know, we now have everything in 2D, but we want to know what this position in space of each pixel is. So those are the 4 maps for the 4 outputs that we render first. But at this point in time, we don't have our end result. What we now are going to do is, for every light in the scene, we're going to do a pass. So first, we're going to do a pass that takes the direct light and the ambient light into account, and that makes our initial screen. And we just basically read from those 4 textures, and we figure out with those light, or with the direct light, what the color should be, and we render our image. But then for every one of the other lights, we basically render a sphere with the wherever that light would potentially have an effect. And then again, we sample the 4 textures. We figure out where is the what is all the information about that fragment. So now we know that this is the hat. We're not lighting the tile. We're lighting the hat. We've already passed that information. That's another optimization of deferred rendering. But it's then coloring that light. But it's only doing that for the pixels that light actually illuminated. So on face value, deferred rendering sounds amazing, and for a long time it was. But then there was a point where things got better. There's no other way to put it. We're certainly starting to get games that are running at 144 frames a second instead of at 60 frames a second, because everybody is getting 144 hertz monitors. We're getting 4K monitors. We're getting PBR rendering, where it's not just a specular highlight that we need a value of. We suddenly need our metallic index. We need our we need our roughness value. We need we need to know what is being reflected into that part of the hold on one second, I just need to check what is going on here. Okay, that's all good. Okay, so suddenly, first of all, we're having 4 buffers that we're rendering to, which are now suddenly required at 4 times the size. So you can imagine the memory bandwidth needed at that point in time. we are storing much more information about the scene because we suddenly need far more information about all the materials. And there is suddenly a lot more information needed to do the light calculations that, that become more complex. So you can see that at that point in time, all of a sudden, these things start to demand a whole lot more about deferred rendering. Now, the other thing, by the way, which is really interesting, is deferred rendering can't do transparent materials. So in every game engine that implements deferred rendering, if it has transparent materials, the transparent materials are done with a forward renderer. So go figure. Anyway, those are the two main approaches that were used for the longest time. So Godot 3 went back, I guess went back, because I think at some point there was a version of Godot that did have a deferred renderer way long ago. Don't hold me to that, by the way, because that was way before I got involved. Although I built, the engine that I was working on for myself a long time ago as a deferred renderer as well, which is a lot of fun to build. But Godot 3 is a forward renderer again. So the whole thing that I explained before, where we are rendering a pixel, doing that with the Fragment Shader. The Fragment Shader is doing all the light calculations needed to figure out what the color of that light is. And especially when you look at PBR, when you look at being able to do things like reflections and stuff like that, that really is... it's a good approach, but it has that limit of the number of lights that can affect a pixel. Simply because you need to have too much information available at one given time. But also it's a very inefficient loop if you look through that many lights. So Godot 4, time's moved on and there's newer techniques. There are more improved techniques. And one of them is, before I forget, deferred rendering on a mobile is a big no-no as well. Just because of the way that the deferred renderer, having to create all these buffers and then reading from these buffers to do a second stage, the whole architecture of how a mobile GPU works. GPUs, they have what's called a tiled approach where basically the screen is divided up into tiles, and every tile is rendered one by one. And it's basically doing all the vertex calculations first of the whole scene, and then it's doing all the fragment calculations of all these tiles. And once you have these staged approach renderers, you create a whole bunch of waypoints that just waste cycles on your phone and slow everything down. So a forward renderer, again, for mobile is much more efficient. Mobile is much more optimized to do that sort of stuff. So Godot 4 is going down the route of what is called a clustered renderer. So when we're looking at the high-end rendering engine, we're actually doing a few passes. First thing that we're doing is that we're rendering our whole scene, but we're just rendering depth. And it's called the depth prepass. So basically, we're rendering our whole scene without any lighting calculations whatsoever. We're purely rendering where everything is. And one of the really cool things about that is, for instance, when we're looking at our mage over here. Let's move our mage over here. It's even a better example. So now, when we're looking at a lot of pixels around here, we have our tile in the background that are being rendered. Let's say in the worst case. Let's say that the order in which we're rendering things is inefficient. So we are rendering that tile, then we're rendering our mage on top of that, and then we're rendering our knight on top of that. So any pixel, for instance, over here would actually be rendered 3 times. It would be the tile being rendered, all the lighting calculations for all the lights are being done. Then on top of that, we have our mage being rendered, maybe even multiple vertices, polygons of our mage, and then finally we have our knight being rendered, and each time we're overwriting that pixel. So we're having a whole bunch of calculations. Now, if we do a def prepass, the nice thing here is that we're doing that without any of the lighting calculations being done. We're just writing to the depth buffer. And then when we render our scene for real, the depth buffer can immediately, when we try and render this tile, it can immediately discard all the pixels that are not visible, that are hidden by the things in front of it. And therefore, the more expensive parts of the rendering, namely the lighting of the tile, that is suddenly not done for all the pixels of this tile that are obscured by the mage and obscured by our knight. Then we render our mage, and the same thing goes. Any pixel of the mage, any fragment of the mage that is being obscured by the knight is not rendered because the depth buffer already says it's behind something. I'm not going to render those fragments. So we already have that optimization in there by doing a pre-pass. But the nice thing also is that now that we have a pre-pass, we basically have a depth map, difficult to pronounce, a depth map of the scene. Knowing, therefore, first of all, we know what's on the scene, but also, we have, an idea of, that. Now, the nice thing about that is that when we now look at our lights, now this one's off in this case because our mage isn't close enough. But let's say in this case, we have our 3 lights turned on. What we can now do is before we actually start rendering our scene, we can check the light influence of this light against our depth map to see which fragments in the influence of our light are actually being lit. Without doing any of the calculation, we just want to know, does this fragment over here receive light from this light or not? And in a clustered renderer, what we're doing is we're doing that pass, but we're doing that in a compute shader for basically tiles. And we're not doing that for every individual fragment, but we're doing that for tiles on screen. So let's say that we have a tile of, for argument's sake, 100 by 100 pixels, and we just have a grid like that. For every tile, we're quickly checking between the minimum and maximum depth of that tile. We're checking if these lights potentially light something in that tile. And then we just add it to a list. And then when we're doing our real pass, our normal forward renderer pass, and we're rendering, that little pixel over here for the helmet of our knight, we know exactly which of these 3 lights, or which of these 10 lights, or which of these 100, or maybe even which of our 1,000 lights in our scene are actually lighting that fragment. And they usually turn out to be 2 or 3. In some really high stress tests, you might find out that at tops, you might get 5 or 6 lights lighting a single pixel in a normal situation, unless someone does something really, really weird or crazy. So you suddenly have this stage in between before you do the actual color rendering of your scene. You have this step where you can figure out exactly which lights affect a fragment, and therefore you do the bare minimum amount of work to actually determine the color of that fragment. And it's so efficient that it blows deferred rendering out of the water. It is there are games out there that are literally rendering thousands of lights in like a street cityscape with this methodology, just because it is so efficient in figuring out which fragments are actually lit by which lights, which means that when you're doing because the lighting calculations are the most expensive part of the rendering pipeline. So if you can minimize the number of those calculations that you're doing, first of all, by not rendering fragments that are then after that obscured, which is why we're doing our depth pre-pass, but then also we're minimizing the number of light calculations we're doing because we figured out how many lights light up that one pixel. All of a sudden, you get your most efficient path to lighting that one pixel. And just to complete the story when we're looking at the Godot 4 renderer is after this image is then all rendered, there is one final pass that is being done, which is a post-production pass. And that's the pass that does things like tone mapping, that does things like glow, depth of field, all those sort of things. They are a post-process. So it basically takes our rendered screen and it throws it through another fragment shader, which is just rendering a big square onto a new buffer. It's taking our current render as input, and it then is doing all our post-processing. So those basically are the 4 stages of the Godot 4 renderer. The Godot 3 renderer has 3 of those stages. It does the pre-pass and def pre-pass. It then does the fragment shader pass or the forward shader pass. But then traditional, how many lights are shining on my, or potentially shining on my character that I'm rendering. So I'm doing more work than if I do the clustered approach. But then it still does a third post-production pass over the screen to create the image that you finally see on screen. Hi, Rahul. How you going? Oh, I'll have a look. I'm still sort of talking about the work that I've been doing this week and sort of doing a bit of an introduction of, okay, what are the different shader techniques that have come before? What has Godot 4 settled on right now? And then, the segue into, but now I'm on a mobile phone, which is a tile-based renderer, which does not like the fact that we have a 4-stage rendering setup, nor does it like the fact that we're using compute shaders to figure out what lights are affecting each pixel, which on the top flagship mobile phones is only now just about becoming available. But on, most of the phones that are in the market, they just don't have that capability. They don't have that ability. So we're suddenly stuck with a render engine that is incredible on the desktop, but it is it struggles on mobile. And we knew that, going in, that was always the plan from the beginning, to have a variation of the renderer that was toned down, that was more traditional forward rendering to support the mobile game development. Because, you can't, that's the problem. That's what a lot of people don't get, I guess, is you can't have a renderer that works in all conditions. When you want to create one renderer that would work on any device, you're going to create a renderer that's based on the weakest link. You would create something that would have concessions because it needs to be running on mobile hardware, or it needs to be running on lower end computers, and therefore you won't be able to implement the higher end functions or features that people expect from a modern game engine nowadays. You just can't. You can't combine it. So and that's the same when you're in Unity or when you're in Unreal. What you'll see is that they have different versions of their renderer. A version that is meant for low-end machines and a version that is meant for high-end machines. Just because only high-end machines with the latest GPUs have certain capabilities that we want to be able to use to improve what Godot does on screen. Rahul, yes, that is actually one of the reasons why I raised my hand in helping build the mobile renderer, is because it is, for me, the stepping stone on then getting an efficient renderer for VR, because VR has got similar issues, right? Everything is higher resolution. You're targeting mobile devices nowadays with the Quest, and there's now a YY or whatever those guys are called. They're coming out with a new VR headset that's Android based. You got the Tilt 5, which is an AR headset that no, that one's PC based, so that one would actually still be fine with the newer renderer. But you're seeing that you are running VR on devices that again have these highly specific GPUs for these types of markets, but also for PC VR. Just the fact that VR uses a lot more processing power, it runs on a much higher frame rate, it has to render 2 eyes high resolution, then has to apply lens the deformation on those images before it can actually output them to a headset. It often needs to render a third camera for spectators, all that sort of jazz. So having a renderer that is able to run faster or is able to run on these lower end devices by giving up some of the higher capabilities is just something that is really needed. So the mobile renderer that we've got planned is going to be a single stage forward renderer. It might have a 2-stage. That's something that I'm still discussing with the guys of, okay, how we're going to do this, because right now, like Blur, for instance, or Glow, you can't do that in a single stage renderer. You have to render the image, and then you have to do a post-production step, which again on mobile is a little troublesome. But there are other parts of it. Not everybody is going to use those sort of features. A lot of people are going to be happy to turn those off on the lower end devices. In VR, it might actually be something that you can offload to the compositor, to the part of the VR SDK that's actually doing the lens distortion, so you can optimize it that way. Because in VR, it's always going to be a 2-stage process. We render our square image, and then we are doing a second stage that actually does the lens distortion and creates the output. So you already have a 2-step renderer. If you then turn that into a 3-step renderer, 3-phase renderer, then yeah, you're really taxing that tile-based renderer. So Bailey, as far as I'm aware, we already have Web GPU up and running because that's what the HTML version of Godot runs on. So, and good to hear that you're working on your game again. So that's really good. All right. Well, shaders, as far as I'm concerned, can be hot news every day of the week, because that's really what drives games. And yeah, the new Godot shaders website is really, really cool. I think that's a really cool initiative, and I hope that site becomes very successful. I don't know what CryEngine does either, but knowing that they have been on the forefront of these sort of techniques, I would not be surprised if CryEngine has been one of the first engines to adopt something like clustered rendering. There's a couple of other versions of it. So there is another one, I always forget the name, Index Deferred Lighting, I think it's called, which I actually implemented some years ago for myself to just see how it works, and it really works really well. It's kind of a hybrid. So a lot of people get turned off by it because it has deferred in the name, and it has nothing to do with deferred rendering. It's just doing exactly the same as the clustered step does, the clustered lighting step does in Godot 4, but instead of rendering it to through a compute shader that is able to do proper buffers, the way that is organized is think of it as real data buffers. So there's no problem that the tile over here has 0 lights while the tile over here has 3 lights. That obviously this tile has an array size of 0 and this one has an array size of 3. Well, normally you can only render to textures and you can only have one color output. You don't really have support for that. So with the indexed deferred lighting, we're basically doing exactly the same thing. We're doing a pass that is just looking at what fragments, what pixels are being influenced by this light. But we're rendering that to a texture and encoding those lights, and it bottoms out at 8 lights. So, or depending also on your configuration and the resolution of that map, it bottoms out at a given time. So, it's a nice in between one that works well on the GPUs that don't support compute yet. However, it's not suitable for mobile because it is an additive renderer. So the light, each of these lights is rendered as a sphere into that light map, just to add itself as a light to what's already there. There's a little trickery going on with blend modes to make that work, but blend modes require a read and a write, which again is something that starts getting questionable on a tile renderer. I'd actually have to try it. It's actually something that is on my list. I do want to see if we can make that work. But I don't see that as a realistic option. Also because, again, it requires the def pre-pass step, which, again, on mobile hardware will just slow you down instead of speed you up. Simply because of the tiled render nature, creating that wait state in between, and all of a sudden whatever you win by not double calculating the light of a fragment because something's obscured, that profit gets lost by waiting on the pre-pass to finish. So yeah. So I'll come back to the map in a second. Actually, seeing, I think I've pretty much caught up on all the things in chat. Let's have a quick look at the minimap. Because indeed, the minimap is just a camera thingy. So, did I hide that in the UI? No, I did not. Where did I put it then? That's always the downside when I'm coming back to something that's... No, it should be in the UI. No, turn on state. All right, good question. Where did I hide our minimap? It's just a maze. That's a room. Did I put it in my camera rig. Haha, because I'm following everything. So my camera rig is just a point in space on which I'm focusing. So that becomes always linked to whatever character is current. This is our normal camera, so that's on a pivot looking down at an angle on our character. So that's the camera that we're always using to look at our characters. But then we also have a viewport in here. So this is just a viewport configured to be just a square 250 by 250. Maybe I should make it 256 just to make the power of 2 happy, although I don't think that is as important as it once was. We're having a look at point, so that is just something that we can place at the same position as our camera rig, because one of the downsides, quote unquote downsides, of introducing our viewport node is this is not a 3D node. So we're losing our positioning in world space. So our look at being a child of our map viewport, which doesn't have any location in space within our world, that means that our look at point is always going to be placed relative to the origin point of our scene, the 0, 0, 0 point of our scene. So we need to place that in the right spot. And we're going to be doing that with our remote transform. I'll look at that in a minute. And we just have a camera that is linked to our look at point, so that nicely moves along with the look at point, but it's moved a bunch to the top. So we're 10 meters at the top. And this thing is, can we see it? Why is my gizmo? Oh, that's right. This is an orthogonal, I can never pronounce that word, camera. So we can see the big box around, but it's a camera that looks straight down, and it's set up as an orthogonal camera, which means that there's no depth perception. There's no perspectiveness to this camera. And that is rendering our scene from a top-down view into our viewport. Now we have a remote transform. So if we collapse those, we see that that is in line with all the other ones. So this is going to be positioned wherever our origin is. And all that our remote transform is every frame that's copying its position to another node. And it's actually copying its position to the look at. So this ensures that as our camera rig moves through the world, because it's linked to our character, so as our character moves through the world, that look at point is also moving. Therefore, our camera is also moving. Therefore, we're always looking down on where our character is. And the final part of this is a texture rect, which is actually the thing that renders out the viewport. So we can see that there's a texture here, and that texture is linked to our viewport. All right, the camera has an option for Doppler tracking. Okay. Godot has got spatial aware sound, which is really cool. So if I go in here and I go to audio, you can see that I have an audio stream player, which is a normal audio stream player, which will play a sound at a constant volume, at a set volume. But we also have a 2D and 3D version of the audio stream player. And these are actually positioned in the world. So obviously the 2D one for a 2D game and a 3D one through a 3D game. So here I now have an audio stream. And let's say that I child that to my mage. And I make sure that I zero out my transform. So that, oops. Let's move it a little bit up. So that sound is now positioned on my mage. That now means that Godot knows where this audio is going to come from in space. Now, the problem that we of course have is we can have multiple cameras in our scene. We need a way, especially when we do compound things, we need a way, first of all, to tell Godot which camera to use as our position, so that the sound is actually calculated based on where the actual player is. So not the character that we're controlling, but where we are in relation to the character, so that the further away the character is, the softer the sound gets. The more to the left the character goes, the more to the left the sound it seems to be coming from. The more to the right it comes from. But that is purely positional in the sense of volume. Do I hear something on the left? Do I hear something on the right? Do I hear something far away? But now imagine a moving object, right? So the funny thing is that if a object is moving towards you, because of the speed of sound, the difference, basically the speed at which the object that is traveling affects the speed at which that sound travels away from that object, and therefore it affects it how quickly that sound reaches you. And that has the funny effect that as a character or a sound, something that produces sound moves towards you faster, it pitches that sound up. If it moves away from you, it pitches that sound down, which is called the Doppler effect. So when you enable that, Godot will start to simulate that effect by looking at how fast the sound node, the audio stream player 3D, how fast that is moving away or moving towards the camera that is being used as the camera that is, represents the player's position. So in our case, that should always, in our camera rig, that should be our camera here. Not this one. That one is our map looking down. It has got nothing to do with sound. This is the camera that is making us, that is making us, what's the right word? That's representing us as the viewer. So what we can see here, well, first of all, we then have the Doppler tracking, which then works together with having Doppler enabled in there. So this is telling, okay, use this camera, the speed at which something that produces sound is moving away or towards this camera, including keeping track of the speed of the camera itself, to figure out, okay, what's the pitch adjustment that I need to do? There should be another, no, that's on the viewport. That's right. So if I'm actually rendering out a viewport, so I'm not using the main viewport, but I've got a secondary viewport. This is very important VR, where we're often using a viewport to render to the HMD. That's your primary viewport that represents the player. So you will want to turn the audio listener on that viewport, which again is then, that's the viewport. The camera inside of that is the camera that's going to be used to do all the sound calculations. That camera then needs to have the Doppler tracking turned on to make sure that it does that pitch calculation. And our sound needs to have the Doppler tracking on. All those things need to all be enabled for that effect to work properly. When you're looking at reverb, let's have a quick look at audio. Why not? Oh yeah, because we were using, I actually removed the add-on, but I still have a channel in there because I was changing the sound of that. You've got a tab here called audio. Once you set that up, you'll see that there is a default bus layout trace file, so you can have multiple setups for the audio bus. I wouldn't really know why you would be doing that. There might be uses for it. I'm not sure. I tend to have a single setup. But very few people play around with this. I'm not even sure if there's a lot of good tutorials on this. But one of the things that you can do here is you can actually start adding buses. And the idea, there's two parts of this. One is that you might want to predefine certain effects that work in for certain environments. But the second is that you might want to divide up your audio into logical groups. So obviously your master bus, that's your output, your final volume control. And generally speaking, that would be, I'm actually going to delete this because I'm not using that anymore. It was fun last stream using that ridiculous typing thing, but I turned it off because although I want to use something like that, I thought it was a little bit too annoying. So you generally wouldn't be adding any effects to the master bus because that is your final, all sounds go through the master bus. So you really just have that for your final volume control. And, one of the things that we'll eventually even do in this game, and let's actually put that onto our to-dos for at some point in time, settings, window for audio, volume control. There we go. So yeah, you would put your master volume effect in your settings and you would have that control the master bus. But then let's say that we have a bus for music. So if we have background music playing, we want to make sure that that goes through there. So I'm going to delete this node for now. And I'm not going to set this up because I don't have background music yet. But I just wanted to show how that works. So background music is one of those things which is not spatial, which is just playing in the background at a constant volume. We would have that just playing, and we would set this one up to say, that's going to go to music, and we're going to call that background music. And then whatever this stream is playing, so whenever we assign a music file to the stream, that's going to be the background music that's playing. That's going to go through this bus, and then it's going to go through the master bus. Again, something that probably wouldn't have effects on it. But you might want to control the music individually. One of the things that a lot of streamers like is to be able to put music off, especially because music in games often, especially, the higher budget games, they'll feature proprietary background music. They will have licensed tracks that they play. Well, if I'm a streamer and I'm playing your game and, that licensed music starts playing in the background, then I'm screwed as a YouTuber, as a Twitch streamer. So, I want to go and make sure that happens. I could have, in the same way, a dialogue bus. So I want to make sure that I can change the volume of the dialogue that is being spoken between the characters. I would want to have an effects bus. So as my characters are fighting and the swords are clashing, I might want to go and do that. And I might want to have an area bus. So let's say that here we are playing sounds that are inside of a certain tile. So let's say that at some point in time when and again, this is also the nice thing, right? I was just talking about, I want my spatial audio in most games to be from the perspective of the player, so the main character. But what if I want to have my spatial audio working based on our mage or our selected character? I don't want it to actually be based on where my camera is. I want it to be based on what my character is hearing, so that I actually hear the surroundings based on my character. And I could have my flame over here be affected by that. Now, I don't have any sounds in this game yet, so I can't really demonstrate that sort of stuff yet. But what I eventually wanted to go to is when you have something like that, you can actually add a whole bunch of effects on that bus. So I can, for instance, have a reverb in here. So let's say we're in a dungeon right now. Makes perfect sense. So I might want to set up some reverb for any sounds playing inside of my game. Even for my effects camera bus, I might want to actually have a reverb on that one because we are inside of this dungeon, and that's actually a good reason why you might want to have multiple bus layouts because you might want to load different layouts depending on where you are, or just turn effects on and off depending on where you are. So Godot has that ability to already apply a whole bunch of sound effects on top of your sounds. And it's just a matter of creating effects or buses, putting the effects on there. And my game window does not get recorded in OBS. I do use OBS for streaming, but I use an Elgato recorder. So I'm actually using two PCs here. I have my high-end laptop running my development environment. I then have my Elgato attached as a mirror device, and then I've got my second laptop that I'm using as a streaming laptop. That is actually capturing what receiving what the Elgato captures, and I'm just using OBS to stream that out so that I can overlay my camera and do all that sort of stuff. I used to, when I did my tutorials, I did used to record directly from screen. And especially with laptops, especially when you have dual GPUs, OBS is really, really gnarly. It has really big issues trying to screen record properly. You can make it work. You have to make sure that especially when for instance I'm using NVIDIA GPUs here, so you got your NVIDIA control panels. You have to make sure that your OBS is running on the GPU that is actually running your the thing that you want to capture. In which case, it also means that you're generally capturing, like in our case, capturing Godot itself, not capturing the whole screen. And then it tends to work pretty well. But if you're on Windows, the thing, you don't have a second machine, you don't have an Elgato or other capture device. The best advice that I can give is press Start G, and that brings up this wonderful thing called the game bar, and that actually has a capture recording built in. And but again, that is really nice for recording for making tutorials that you then later on edit. It has a streaming mode, but I don't really think that you have enough control over it. So in the end, short answer is yes, I use OBS, but I don't use OBS to capture the screen. I use an Elgato to capture my screen. I just use OBS to stream it. Or to record it if I'm doing videos, because I'm using that same setup. I'm using videos. Do I have any sounds? It might go and dungeon assets. Let's go sounds. I just want to have a sound in there so that we can play around with the sounds a little bit. Downloads, no. Let's just go into my weapons tutorial. You know what? I'm actually just going to go and copy. I'm just going to copy that over. Delete that folder. Just so that we have some sounds to play with. That also means that I need to make sure that that is being directed to my Elgato, else you guys can't even hear it. And that probably also means that I am going to want to make sure there's enough volume there for that. So hopefully we'll be able to hear that. That might actually end up being really loud. So that's just for fun. Go and say that here we're going to go and load up one of our sounds, which of course is not going to be our background sound, but just as an example. I have no idea what that is, but you'll see. And if you play that, oh, I can't hear the sounds. That's not very good. All right. I don't have my headset here. I didn't think that through, because if I am going... Oh, hold on. I can do that through our good friend. You guys might get a little bit of an echo here, then. That's the problem. If I play the sound on my laptop so that I can hear it, then my mic picks it up, and you guys suddenly hear it both through, through you know, the fact that the Elgato is recording it. And all right, I think I'm gonna have to think that through a bit. So I'm gonna have to remember next stream to have my headset ready, because I have my headset in the other room, unfortunately. Yeah. So I think it's something that I'm going to have to do on a separate stream at some point in time. But I hope at least... let's go and clear this out. I need to find some... I'm just going to delete this for now, because I don't want that to be... Yeah, I need headphones, but my headphones are in the other room, and... Well, I could go and get them. I think that is for another day. Anyway, you know, obviously without really trying it out and showing what it does, we have, you know, at least a little bit of an overview of, okay, what can Godot really do with sounds? And again, it's all a matter of, at some point, you then add in, you know, a sound player 3D. So on our Mage, so... Mage sounds, and I would be throwing that onto the effects bus. And in this case, I wouldn't actually care about Doppler, but I would care about the other things. And whenever my Mage, you know, let's say my Mage, let's say my Knight, let's say my Knight swings its sword. The Mage, obviously, I could have done sound effects for you know, casting spells, I guess. But whenever my Mage, you know, swings a sword, I would play a sound which is like a swooshing sound. And then if it impacts, I would play, you know, an impact sound or something like that. And, you know, I would either throw those all through the effects bus, or I might have multiple effects bus, because, of course, that's the... No, I would throw them all through the effects bus. I would then have potentially multiple sound channels, because every audio stream player can only play one sound at a time, but I can have 3 audio scene players. And if they're all 3 playing, then those 3 sounds will get combined, thrown through whatever buses they go, then the buses all get combined, and then they're thrown out to whatever device you've got attached. So that, in a nutshell, is what Godot's sound effects are. Now, obviously, that means that these sounds would actually go into our character setup, so they would probably end up either in the Mage itself, or they would end up in the player character scene, so that every character can just produce their own sounds. Anyway, I think that's enough about sounds for today, because until I actually have some sounds to play and to do stuff with, really doesn't make much sense to really dive into it too much. What were we going to do? I had a few things for next stream, so I want to do something... I have not used NVIDIA Broadcast, but that sort of thing does... OBS does that a pretty good job at that as well. I'm not quite sure... Yeah, I guess it could figure out how to filter out the sounds that it is actually playing itself. I wonder if OBS actually has that as ability as well. I need to investigate that, really. I haven't really played around with that too much, but I do know that OBS has got a whole bunch of features that it can do. So I want to do something with the with highlighting the character, so that it's more clear which character is currently in play. Even though the camera is already following the character, I think it's just easier to see that. The other thing that I want to do. Oh. No. Why did it do that? Probably because I still had that selected over there. I just wanted to create a new card. There we go. And here I just want to say for today. Now I forgot it. I got distracted by that. Make effect show the path that we're about to move. Highlight current character. Now what was the third one that I just thought of and now forgotten? That would be a good one to do today. See if it comes back to me. Yeah, when we're looking at the audio streamer, indeed, it is calculated based on the head position and not on the individual ear positions. The other thing is, it's a pure left right. There's no it's a pretty straightforward implementation, right? So if a sound is coming slightly from the left, the audio on the left ear will be higher than on the right ear. And it can even be in a way that the right ear gets nothing, everything goes to the left. And it does that a little bit too quickly for my liking, especially in VR, where you basically want to have both ears hear the sound. But it even goes to a point where your Doppler effect could be slightly different per ears, and the offset of the sound can be slightly different to your ears, and all those things affect your brain processing the position of that sound. And it's kind of like stereoscopic with eyes, right? Because the left eye sees something slightly different from your right eye. It can determine distance and the relative position of an object that it sees. And it does the same with sound. The other thing, which, and there is actually someone who is working on that, who's in the XR channel. The other thing which is really cool, like we were talking about reverb, for instance, which simulates the sound bouncing of walls. But it's a global effect. It's it works good for simulating I'm sitting in a big hall or a big room and the sound is echoing off the walls of that room. But when you're inside of more complex environments, sound bounces off walls. So you could have a sound playing in a different room and you would still hear it in a certain way as it is bouncing off. And it's almost like ray tracing with visuals, right? Where you're seeing indirect light that's bounced off of walls and might be coming from, a place that you actually can't see yourself. And we are pretty good at understanding sound in that way. So yeah, that's a really interesting little thing. So there are sound libraries that simulate that and are able to do really fun things with that. And with VR, that does become important. Well, depending on what sort of game you're making, right? If there's something that where hearing correctly where the sound is coming from, those are really cool effects to have. Yeah, so you can use the game capture in OBS, and as long as it runs on the same GPU, it generally works pretty well. It's if you have only one computer and you want to stream or record, then that works pretty well. I just made my life harder by using laptops. Yeah, it does some really cool things with the NVIDIA one. Also, the background removal that NVIDIA now has. Obviously I use a green screen, which makes life easy. But yeah. And it all depends when you look at something like OBS or even the Windows game bar or anything like that. As long as it can use the hardware to do the capture, it shouldn't affect the performance of your game. A lot of modern GPUs have capture features built in because they know that everybody's streaming nowadays. But if you use old-fashioned screen capture, and that's especially when you're capturing the entire display, you're not just capturing the game that's running. That's pretty CPU intensive, the way that grabs the images. Although there's probably hardware accelerated versions of that as well. And I know OBS nowadays is able to use those things. So again, on a laptop where you have two GPUs competing, it gets a little tricky. Yeah, I don't have a mechanical keyboard anymore. I might go back to one because I did love them. But yeah, you can hear them. It's just kind of fun. Yeah, Big Sur, there's a whole bunch of them. Oculus has got their own spatial audio library as well, which is completely geared at VR. So yeah, hopefully at some point there's going to be a good open source version that we can embed into Godot. Although, again, it's one of those things where it's a trade-off, right? A lot of games don't need it. A lot of games, you get no benefit out of an audio library that can do, full rendition of how audio travels through the 3D environment that you have. And then there's games that really flourish. I can imagine someone playing an FPS game like Call of Duty or something like that with a headset on. Those sort of games probably will benefit from really accurate sound reproduction because the top level gamers, they use sound as much as what you see on screen to figure out if someone's about to ambush them or anything like that. So you can do some cool things with that. Yeah, the dynamics microphones, they do directional sounds a little bit better. That's true. I think this is just a normal condenser mic that I'm using, but it does pretty well. And yeah, horror games. Yeah, I think Resident Evil 7 is scary enough in VR as it is, and don't know if it really needs that much more accurate sound reproduction. But you got people who love being scared, so it is one of those things. Yeah, I just have a really cheap Logitech keyboard. A good one though. It works. I do want to get my RGB mouse that I have is like a $10 gaming mouse, a Gecko gaming mouse. It works pretty well, but it squeaks. At some point, I want to get something a little bit more respectable. Looks nice though. It's got a little gecko on there. But yeah, it's a very cheap feeling mouse otherwise. And it is a cheap feeling mouse. Yeah, Alien Isolation is an amazing game. Yeah, Counter-Strike is not a good example where indeed sound would be really good. I'm into Apex. I love playing Apex, Apex Legends. And everybody's always complaining about the sound, that it's and especially right now, I'm loving the new version that came out, but it has some serious sound issues at the moment, which really ruins the game. I had a few games yesterday where all of a sudden the whole team jumps on your neck and you just don't hear them coming, and it's so important that you actually hear the footsteps, you hear that someone's sneaking up behind you. But no, I had a team running full speed at me and coming over the hill, and all of a sudden shooting me in the back. Never heard him coming. Really annoying. Oh, that's a good trick for CS:GO. That makes it hard to sneak up if you put that behind the camera. All right. Come on, mouse. There we go. So let's go and figure out highlighting our player. So, okay. Let's see. That's in our global state. Whenever we change our character, then we go to the first one, and then we say current character node is current, became current character. I wonder if we what I want to do. Let our current character know it's no longer the current character. Boom. Oh, if let's see. Deco, how to learn GD script fast. Watch lots of YouTube videos. That's the best advice that I can really give you. Read the docs. Watch videos by GD Quest or Heart Beasts. Actually, the best resource probably. Is it this one? No, that's resources in there. Hold on, let me just go to the latest. And then probably it's in a community. Tutorials and resources, that's what I was looking for. So yeah, most of the people listed here do really good ones. You got your text tutorials. But yeah, definitely people like Kids Freaking Code and Heartbeats and Game Endeavor and GD Quest. A lot of them have really good tutorials that you can really pick up GD script very quickly. But other than that, you know, it's watching lots of tutorials and just writing games. Just start building stuff, and that's really the only way that you can learn fast. What's the opposite of became current character? Not unset current character. We're gonna call that. That means that on our character script, we need to make sure we have a template function. There we go. And our player character, we're also going to put that function there. So now we have on our became current character that we can highlight it, and then on our unset we can remove the highlight. We're never going to highlight our enemy characters because obviously we don't want to see, you know, if an enemy is hidden somewhere, we don't want to suddenly light it up because it's become selected. That doesn't sound like a very good idea. All right. Space Engineers is a good sound. I've seen a lot of videos about Space Engineers because it looks like a really cool game, but I just have never had the time to actually play it, so I don't know how good the sound is in there. Yeah, Apex sounds is really buggy. I don't know why. You know, it is really hard to do sounds good. The biggest problem that you have with sounds is the more sounds that you play at the same time, the more chance you have that your sounds are going to become distorted. So you can't just pile sounds on top of each other. The other thing is that all the mixing of the sounds obviously has an impact. Although I would imagine that mixing sounds isn't as intensive as rendering, a scene at 144 frames a second. So, I remember back in the 90s, early 2000s, not late 90s even, with all the music players that we were building back in the days. I built an old mod player and a GM mod or a Gmod player at some point in time. That was an 8-track player. If you can mix sounds on that old hardware pretty effectively and efficiently, I'd imagine you could do it a lot better on more modern machines. But yeah, there are issues, especially with, like I said, the more sounds you add together, the more likelihood you have of sound getting distorted and stuff like that. So yeah, not my area of expertise, by the way. I'm not an audio guy. So then again, when I look at the current sound issues, like the ones that are in the current patch, in the current new game mode, which is a really cool game mode, by the way. I do really like what they've done with the the zones that are suddenly coming in, and it really does mix up your gameplay, but it just screws up the sound completely. And I don't know why. I can't think of a good reason of what they would have done to really screw that up. Now, again, I have no idea how sounds work in their engine. The comparison I have is to how sounds work in Godot. And yeah, I have no idea what the limits of Godot are. I have no idea at what point Godot starts struggling. When if you have 1,000 audio players in your scene, will that even work? I don't know. Can you have every character in the game produce, have its own audio player that's playing spatial aware footsteps and stuff like that? I have no idea how well that works. You got 60 characters in the game. You would do, for every character, footsteps and gun sounds. So you're talking about 120 audio stream players. If you would do this in Godot. I have no idea if it would handle that, or if it, especially if they all play at the same time. I don't know. You got your background music, you got your environment sounds, so there are a number more, but the bulk of it will be, the 60 players are running around playing at the very least footstep sounds and gun sounds, and then potentially a third sound for dialogue. So then again, I think when you look at dialogue, you would only hear the dialogue of your other teammates. So I don't know how much that plays into it. Never built something like that, so I really can't comment. But it is a shame that they are having problems getting that right. Yeah, the funny thing for me is this is a newer, so that's a brand, newer microphone, which is a $30 budget microphone I got off of Amazon. And newer, from what I understand, is very hit and miss. This one seems to be okay enough. It's not perfect. Whenever I hear my voice play back, it sounds a little bit more hollow than what I sound in real life. But for my purposes, I'm pretty happy about it. So yeah, so audio not playing, when you look at audio not playing, what I'm guessing, basically there's two scenarios that I have noticed. One is if you have something like an audio player, and I imagine that other game engines have something similar like this, is you can do two things. Is you can have an audio player for every type of sample that you play, or you can have one and you can tell it which sample to play. The thing, of course, is that an audio player can only play a single sound at a given time. So if they limit the number of players or number of objects that produce sounds, which is really the way that I probably should put it, it is possible that if there are too many sounds being played, if they go over a limited number of buses or of audio objects, that it might start to play a footstep, but then it gets overruled by a gunshot from another gun or something like that, right? And that's usually what cuts off a sound, or and then it doesn't end up getting played at all. The other possibility is that they have a maximum the number of sounds that can play at any given time. And when the maximum number of sounds are playing, and you then start playing a footstep, and I think this is how Apex does do it, because that's something that was talked about in one of the dev streams, where they were saying about how they prioritize sounds, so that if there's too many things producing sound at the same time, they would prioritize footsteps over dialogue or something like that. So I can imagine that those are the sort of things that would cut sounds off or prevent sounds from not being played at all. But I think one of the problems that they probably have in a game like Apex, and Modern Warfare, of course, is very similar. Is filtering out sounds that are coming from things that are too far away. And that's always a very difficult thing. You've got these 60 players in a game at the same time. They're all making sounds. You have to be careful when you decide if a enemy is far enough away that you're not going to play any of their sounds. Especially in a game like Apex, where gunshots can be heard from far away. And while I think they can be heard from too far away right now, you do want to hear gunshots from far away. That's what draws you to a battle. And that's what battle royales want to do, right? They don't want people running around the map not finding anything. They want people to hear where the gunfights are and run to those gunfights and participate in them. The famous third parties. And while everybody hates them, they're a huge part of what makes battle royales really intense games. So, yeah. So I can imagine that as a result, it is trying to play a lot of sounds at the same time. Even sounds that are far in the background and might be at very low volume. Sounds that potentially should just be filtered out and said, nope, that's too far away and too low. I'm not going to play that. Leave that slot open for another sound to play. So, yeah. So, Deco, when you look at randomly playing one sound between two sounds, so let's say that I have two different footstep sounds, and I want to play one of them at random, and I just want to choose at random. There are two ways of doing that. One is, if you've got your sound player, is that you change which stream it is. So you would create a script. So what is this type? This is an audio stream. Okay, so I would do something like this. Oh, I'm just going to put it on my player character for now, just for fun. Audio stream for sound 1. And I would sound 2. And then if I look at my mage now, I should have a sound 1 and a sound 2 property where I can put my samples. And then I would just have, a bit of logic that at random chooses 1 or 2 and assigns either sound 1 or sound 2 to my audio stream and then hits play. Now with that option, obviously, if you play the first sound and that starts playing, and then you decide to play the second sound while the first sound is still playing, you interrupt the first sound and you start playing the second sound. The other option that you have is that you actually have a audio player for each sound, and when you choose at random 1 or 2, so that's just there's random functions in GDScript. So you got a bunch of random functions in here. So you would be using rand_i, for instance, which gives you a number between 0 and very high. So you can do a trick like this. So in our case, and I just put it in here for now, just for fun. So I would do rand_i, and I would say modulus 2, and I would say 1, and here we say play sound 1, and of course that's not what I want to do in this function. I'm just using that as an example. And then you do play sound 2. So in option 1, I will be assigning either sound 1 or sound 2 to my audio stream and then triggering play. Or option number 2 is I would have 2 audio streams, one for sound 1, one for sound 2. And I would just call play on the first one, and here I would call play on the second one. That's how I would implement that. And again, I don't know how efficient Godot is in determining how it handles multiple sounds. I think that the node, the audio stream node, is just a placeholder. It's just a node that gives you context. I think that the moment that you hit play, that is actually a signal to the audio server, say, go and play this sound with these things. And the audio server is then going to handle that. So I'm assuming that all the audio streams in your scene that are not actually playing aren't actually a part of the audio calculations at that point in time. But I don't know. It could be that they create slots inside of the audio server, and the audio server is now saying, I have 100 possible origins of sound. I have to take them all into account. I don't know. I don't know how that works internally because I haven't really looked into it. Yeah, I'm lucky, Zahil, that I'm at least relatively in a relatively quiet place. During the day, it's horrible because there are people making noise across the street. So one of my neighbors is currently building, but at night it tends to be pretty quiet. It's only when the weather turns bad. Living in Australia, it's always hot here, so I tend to keep the windows open. So outside noise is something that does affect my ability to record stuff. It's one of the reasons why I stream late at night. Yeah, so indeed, sound cards do a lot of the sound mixing in hardware nowadays. I remember that, back in the 90s, you had to do it all in software. Then the Graves Ultrasound came out, was one of the first really capable sound cards for mixing sounds. I'm assuming that today most sound cards do that quite nicely. And again, that's the big question. I don't know what Godot does. I don't know how much Godot does in hardware, how much it does in software. I have no idea. I'm not an audio guy, so. But I can imagine that's where the limits are coming from. That the sound cards at some point say, well, we can handle up to 32 simultaneous sounds or up to 128 simultaneous sounds. Well, as long as you stay within that budget, that's fine. The moment that you go over that budget, your game engine is going to have to make choices of which sounds to play and which ones to cut off. And as far as whether sound cards are a good buy in 2021, I have no idea. I remember when it was a big deal back in the 90s. You had to have a Graves ultrasound if you wanted to do music stuff. If you wanted to do game dev, you had to have a sound blaster because everybody had sound blasters back in those days. So that's what you developed towards. Nowadays, sound cards are so ambiguous in computers. The onboard sound cards, that are on board on a motherboard nowadays they're pretty serious sound devices, and I, you hear everybody buying, top of the line GPUs. I never hear anybody like, oh, I need to have this sound card to play my favorite game. So I imagine that most people, except for people who, are into audio production, they're absolutely. But I think for people who are into games, I don't know. I think most people will just play with their onboard sound card. But I could be totally wrong. Again, I'm not an audio guy. I'm tone deaf as it is. All right. Anyway, we need to make a decision on how we are going to make our mage light up. Now, when we're looking at a mage, that is set to our player character. And this is where it gets interesting. Because I want to implement this in a way that it's in our player character script. So we have a player character here. However, we don't know what the meshes are that it needs to do something with. Well, again, the thing, of course, there is, if you're doing it to record stuff, or, you have some need for specialty audio equipment, and yeah, it makes a lot of sense to have them. But whether your average gamer would go out and buy nowadays a specialized sound card for playing games, that I don't know. It could be. I'm just not in that world anymore. Like I said, it's, and this was a real big problem in the 90s. I guess Sound Blaster was kind of like your minimum requirement, because the other option was your PC speaker. Don't know if you guys are old enough to remember games that only used the PC speaker. Oh my god. And then, of course, you had, what was it called? Adlib, I think. That was sort of like a MIDI type of device that could do a whole bunch of really cool sounds. And then Sound Blaster was the first one who did sample-based sounds. And you just had two buses, left and right. So all the sound mixing was done in software. And then you streamed that out to your Sound Blaster, and your Sound Blaster would just be able to play a sample for your left ear and a sample for your right ear. And you had to make sure that when the sample ended, you had the next sample ready for it to play. And then the Graves Ultrasound came around. I remember that, because that was big news, because that could suddenly do 32 simultaneous samples. And you could, what you actually did was you loaded the samples onto memory on the sound card. That was new as well. You weren't streaming it out to the sound card. You would load it into the sound card's own memory. And then, you would tell it which samples to play at which note, and you could play up to 32 at the same time. And that was hot news. But again, that was great for us demo guys who were doing, we had audio guy, musicians who wanted to make music and wanted to make the music sound really cool in the demos. So that became the stock standard. If you didn't have a Graves Ultrasound, you weren't part of the demo scene. But games still kept focusing on the Sound Blaster. I don't think the Ultrasound ever got really popular in games. And after that, I kind of lost track of it. But I never really, I focused on rendering. I didn't really focus on audio, so I got actually no idea what happened after that and what the developments were, and I don't even know what the capabilities of my onboard sound card in my laptop are. I've got no idea. Well, I don't know, Big Stu. It's really one of those things where no, the Deco, I didn't add the sounds in there because I need to play around my sound setup here so that I can actually hear what I'm doing. So I might see about doing that next stream. I might add sounds in for next stream. Yeah. So no, I keep clicking on the wrong one. That's not what I wanted. I wanted to add another card. There you go. Let's do that. So let's make sure that we don't forget that that's something we want to do at some point in time. Yeah, so I just don't know what the capabilities of modern audio cards are. I can imagine that might be the next big thing in audio development, that you can actually offload all the all the spatial sound calculations onto the card, that you can tell the sound card, this is where my walls are, these are the surfaces that I want sound to reflect off of. These are the locations that these samples need to originate from. Go and do your thing, and you would have perfect stereoscopic sound. That would be cool. Well, yeah, that's the problem, isn't it, Sahil? You know, that's really, I think, where it boils down to that. You know, everybody knows that you need a top of the line GPU to play a game, so that market is wide open. If you come up with a new GPU that can do something special that all the others can't do, and it's something that really makes a game look better, so that game developers will be on board, you will get sales, and you will probably, you know, increase your market segment. But I think, like I said, I think most gamers don't even think about sound cards. You know, they plug in their headset into their computer and expect it to work. So if you suddenly come out with a new sound card that does spatial audio and it costs $300 extra, that's going to be a hard sell because most people aren't even going to know what that means. And it's only going to be a very small group of people who are really going to want to play at that level, and who benefit from that. And then even then, you got to wonder if, you know, is there really enough added bonus for it? You know, I don't know. I don't know. There might be people who would love that sort of stuff. You know, I really don't know. Yeah, Jolene, I agree. I would say that when you look at that sort of stuff, it's probably someone who's into audio, who's into, you know, recording or whatever, or making music or stuff like that. They might want to do stuff with that. But even then, you know, spatial audio doesn't really. I think the only sort of scenario that I can think of is people who are doing movies. And even then, you know, what's your target market? You know, okay, so now I've made a movie and I've got fully spatial encoded sound. Um, is that really going to play out in a theater? I don't know. Might be enough that, you know, you encode the end product in stereo soundtrack, but morning, man. Hope you're doing well. So yeah, like I said, I'm not an audio guy, so I'm guessing. I don't know, but I would be. I think it's a hard market. You know, I think that people are more than happy enough with what built-in sound cards do, and they don't think of anything that could be extra there. All right. So when we look at our mage, we have our character. Hello. And that's built up of a number of meshes. And those meshes have any number of services. And now the big question is, how are we going to highlight that this character is selected? Now I can think of two ways that we could do it. One is that we swap the actual materials, because one of the things that I'm thinking about is, actually, that's not a bad idea. Because what we can do is we could, when our character loads, we can loop through our nodes and we could grab every one of our mesh instances. Well, we probably want to just get the ones that are on the normal slots, because we don't want to grab the sword, for instance, right? So our knight has got a sword or dagger in this case. Or do we want to highlight the dagger as well? Or are we going to assume that actually all our characters, you know, I just put that sword in there just to show it. But seeing that's something that he'll grab or equip. Do we want that? Yeah, I want to experiment with an outline. Because that's the thing, right? Okay, so yeah, that's the way that we can do this, I think. Because this is the nice thing is we can actually loop through all our meshes, and we can find our materials here. Because the thing that I'm thinking about is creating duplicates of every material as a highlighted material. And what we can simply do is we assign it over here. So we can see this is metal. So in slot 0, we need to put the highlighted metal in there. And we do that for each one of them. Yeah, exactly. Emissions, or I might put an outline on it. I'm not sure yet. We're going to have a look at what's possible there. I'll use a Fresnel shader for it. Of course, the nice thing is that all these materials are pretty straightforward. And then again, at some point, I want to obviously support other things for it as well. But yeah, I think what we're going to do is... that's the other thing. I shouldn't have called that shaders. You know what? And one thing that I've learned is whenever you change something, you are going to want to close everything before you do that. There we go. Now I actually want to create a new path here. And now I want to go and move this guy into shaders. And I'm going to create a new polar materials here. I like organizing my things. There we go. Okay. Now, in K, we have not animations, Dungeon Pack, models, characters, GLTF. We have all our normal materials. Let's go and create... Probably spelled that wrong, but I just want to create a folder in here called highlights. Let's go open our Mage again. Scenes, characters, Mage. Let's just work on her first. And we're just going to do the purple thing. Which is this guy. Okay. Purple dark material. I don't want to... Oops. Don't want to do it like that. I'm going to go over here. There we go. And we're just going to create a duplicate of this. And of course, that's not in our path. Lovely. Materials, highlight. And I'm going to create a material here in the same... of the same name. There we go. Now, let's see. Is there actually an outline? Oh, that's cool. What did it use as a color? Can you make it extra big? No. So we have a tint. I really want to be able to choose a color for that. Anyway, let's do that for now. Let's just start with this. There we go. And let's go back to our character. Where's our mage? here. And I'm just going to test this first. So, surface 1 was that. So in our material, no, it's not like we have a duplicate. Okay. Definitely working. All right. But even though it has an effect in our preview, we can't actually see the effect on our character. That's a shame. All right. Yeah, but I think the tint is just a it's just a calculation based on that. So that's interesting. All right. What I want to try and find out is what is it actually doing in the shader logic? Oh, there's a bug. So the rim is actually a built-in function. How funky is that? Well, okay. We're going to do this differently. I'm going to take this color. And up there. I'm going to paste it in there because I just don't want to lose it. Don't care about anything. This is one of the nice things about these characters is they have really very simple materials. Let's put this in. Metallic is 0. Specular is 0.5. Let's just keep those. All right. Excuse me. I'm going to start with a brand new shader material. And we're going to create a new visual shader. Yeah, we're going to use visual shaders today. Because I've been wanting to use visual shaders instead of the normal ones. All right, let's just recreate the shader that we have here by normal. So one thing that we need to do is start with a color uniform. That's going to be our input, and we're just going to line that up with color. Boom. Cool. And that means that here we should now be able to copy our color and put it in there. There we go. Perfect. There's our purple. And we see that it's not right because it's not the same as the arm because we don't have any of the other things set up. All right. So now I'm going to add in, I think that's a scalar. And we're going to hook that up to metallic. Let's actually go and say this is going to be albedo. All right, and it's forgotten what that is. Luckily, that's still in my buffer. This is going to be metallic, which is going to stay 0. And another one of these scalar ones. We're going to call that roughness. I plug that into the roughness. So our roughness was 0.4. And we're going to add another scalar. And this is going to be our specular. And we're going to tie that in there. And that was 0.5. All right. And now we have no, don't do that. Now we have recreated our shader. And it looks exactly the same as our old one. How cool is that? All right. However, this needs to become our highlights shader. Now, I'm not doing texture support and all that sort of thing, else I need to do more here. It would probably be a fun exercise to do, actually, is create a visual shader that does all the basic stuff. Normal maps, texture, albedo maps, and stuff like that. Just to show how you put something like that together. That might be a nice little subject for a video at some point. Anyway, I think you can do something like this, by the way. Yeah, and then it shows us the options that we have. Anyway, that's not where I want to start. I want to start with my good friends, the Fresnel node. All right. Okay, now one of the things that I'm not sure of is whether if I don't set these up, whether they will actually work properly or if I always need to set that up. We'll see that quickly enough. The Fresnel is a function that is taking basically two vectors, and the further apart they are, the higher the output value is. But it's using degrees for that. So when they're lined up, it's 0. When they're at 90 degrees, I think it's 1. And when they're opposite, it's 0 again, or something like that, if I remember correctly. And we can use that because if we take our normal as a vector, and we create our direction of viewing, which is why it takes the view matrix and the normal of our character as inputs, we can figure out whether we're looking straight onto a material or if you're looking at the side of our mesh. And I wanted, if you're looking at the side, I want to change to a different color. So I'm actually going to go over here. No, is that lerp? Mix. That's the one I'm looking for. I need that one. Okay, that's going into the wrong one. That actually needs to... No, that's an A. Oops. I'm going to put that in there as the weight. And now I need another color uniform. And we're going to call this tint, or outline. And I'm making that B. Because if weight is 1, we should be taking our outline color. If weight is 0, we should be taking our albedo color. And we're going to put that into there. Boom. All right. So now you can see that if I change the color here, the further to the outline we get, the more red it becomes. So obviously, let's go and do that one white. Now this is giving us way too much white because it's going to the white color very quickly. But we're getting close to what we want. So, do we have a power function? Yes, we do. All right. So, let's do some funky things with this. Okay, let's go and do this to the power 2. There we go. That's already getting a little bit better. Now, one thing that I should not forget, this is actually white. That's a bit of a downside. We probably should be testing this with our hat first. And actually want to change the color here. I want to make that a bit more yellow, more green, purple. That's the other thing, of course, is that's just purple because we might make it a value out of that. That's probably not a bad idea, actually. We could make it even more pronounced by making this power value even higher. The higher our power is, the more we're basically pushing our values to the outside. Could also do that with a ramp, but I am pretty happy with doing it like this. So we're now getting this nice little purple glow effect on our character because our character is selected. So I want to go and save this. And we're going to overwrite our purple here with that one. Okay. So that's going to be our highlight color. Now, obviously, we want to go back to our mage's body. And we're going to go clear this. Boom. And I'm not sure yet if that's going to be pronounced enough. We'll see. But there's some other things that we can do to... Actually, that's probably a nice idea. Let's actually go and get our... Let's save this guy. Well, let's get our highlighted color back in here. Save. Let's go into our main scene. Because in here, it's not very clear. I actually want to make our hats do the same. So where is our hat? Hat. Okay, that's also the first service. Load. Highlights. Purple. Okay, because our hat's nice and big, so it's easier to see. So yeah, we can actually see that it is there. Because the thing that I'm thinking about is also making that output to our emission. Oops. What did I just do? Okay. So here's our shader, and we can now see a little bit better what is happening with our shader. Actually go and focus on this guy so that we can do that a bit better. There we go. Cool. Because one of these things that we have here is called emission, and that's basically a color version. That's basically an unshaded color. So let's go and add another vector mix in. Where are you? Why can I not find my vector mix? Oh, that's an operation, I think. Vector function, isn't that one? Mix. Where are we? Is it this one? Nope. You know what? Can I go away? Can I duplicate this? No, that's not what I wanted to do. Come on. You know what? Let's just go like this. Boom. Mix. Oh, okay. There's our vector mix. So for some reason, that's just called mix. All right, that's going to have our same weights, but it's going to be black. Boom. Whoa. Okay, I just said black. Okay. Oh, I got them the wrong way around. Yep. Sorry. Cool. This needs to go in here. And now black. There we go. And that means that our outline always glows. So it's not affected by whether we have light shining on our outline. And actually, that makes me wonder, can I just take this out and just do it like this? And just use, that's actually even better. So, actually, you can go over there. I'm happy for this to go over there. So we're just going to use our outline color. And we're going to use our Fresnel to go from black to our outline color. But we're putting that into our emission. So that is always glowing bright, regardless of whether our character has lights shining on it or not. Now, the other thing is, I'm actually happy by not doing all the materials, but just doing the key materials this way. Yeah, Control D probably should have tried that one. Makes perfect sense. Okay. Let's go back to our mage and clear out our overrides. Clear U. And clear U. Perfect. All right. So what we now need to do is figure out all our It's a little ugly, isn't it? Okay. You think, oh, why is my eye being annoying? So I think one of the things that we need to do is we need to collect what all our mesh instances are. And we're going to do that on our ready function. Do we already have a ready function? We do not. Let's go and put our ready function in here. Okay. Wow. My eye's being weird. I don't know. Okay. So let's create a mesh instance nodes array here. All right. All right. Cool. Let's go and loop through all our nodes. Find nodes. And that's going to be parent node. There we go. All right. And then here we do find mesh instance node. So. Cool. For child in get children. Print child name. Let's just see what happens. And obviously we want to do find all the child nodes of the child nodes, because we want to check if it is instance. Okay, let's actually go and just print it at this point. And we're going to go say pass. All right. And let's go and run our game. All right. Do we have a never-ending loop right now? It's a good question. Because that looks like it's pretty much stuck. Okay. What did I do wrong? Where's my character logic? There we go. Let's go and put a breakpoint here and see what happens. All right. So our parent object is character mage. Perfect. Now we've got our first child, which is mage collision spade. Perfect. And we're skipping that. Now we're going to find the children of our collision shape, and we're finding itself. All right. It would very much help if I'm actually asking the children of our parent. I think that is our problem. All right. There we go. So we can see that now our game starts, and we can see that we have found all our meshes here. Now we also find our prototype mesh. in both of them because we have that in here as well, which is hidden. Okay. Do we care? No, we don't. Because we're going to be checking materials anyway. So that's all good. All right. So what we're now going to do is we're going to say entry, dictionary. Boom. Perfect. All right. Now we're going to say entry, node. Out. Okay. Don't need you anymore. I actually want you at the start. And that needs to be brackets because we need to have a new entry. And here we're just going to say, let's add this to our mesh instance nodes. Back. So now we have a nice collection that we know all the nodes that we have. But the second thing that we want to do is we want to go through all the surfaces that this guy has. And then we only are going to add, so let's do materials is also a new dictionary. And what I'm going to do here is I'm going to say entry materials. Okay, that now I need to check if we have dictionary. There we go. I just need to see, is there an, yeah, there's an empty. Cool. Dot empty. And I'm actually going to say if not empty, then we're going to add it in. All right, cool. And I actually want to print this only the ones that we're actually going to be adding. So that means that now only the mesh instances for which we're going to be doing what was I saying? So only entries where we're doing where we're actually replacing materials, only those ones will be added to our list. Sorry, I got distracted by my phone there for a second. So let's go and find those materials, shall we? So the next thing that we need to do, and for this I'm going to go to mesh instance. All right, so okay, if I do get active material, returns the material that will be used by the mesh when drawing. This can return override, the service override, or the material defined by the mesh. Perfect. That's exactly what we want. We don't even have to go that deep. All right, cool. All right. What I want to do here is actually, I want to copy that because we've checked whether that's a mesh instance, so we can actually do this. Mesh instance. Okay. So that means we know. There we go. We have that as a properly typed thing. No, this needs to be for e in get surface material count, so we can figure out how many surfaces we have. Cool. Active material. Okay, mesh instance. Get surface. No, get active material. That's how we found out that it had an active material. There we go. Okay. Okay, and now what we want to do is, this is a resource. Okay, so we need to go back down to resource. We have a resource path. That's the thing that I was looking for. Path is active material resource path, and I actually want to print that path. All right. Can I show the use of area node? Yes, I can. We can have a quick look at the area node for a sec. This is all working. So let's go have a quick detour to area nodes, because a really nice example is actually in this project. There we go. All right. So note our lights here. And note when our character moves away from the lights. Make that a bit bigger. That light now goes off. We go back. You can see that a light goes back on. Now my my night is the new one. Let's go and move you away, Mr. Knight. So that light goes on whenever our character is near. So if I move this guy out of the way. Oh, that one was still being kept on because of night. It's probably a bad example then. Dang it. Okay. I need you to move further away. There we go. Now that guy should be far enough away. So now we can see that this light goes off when our character moves away, and it goes back on when our character comes back. All right. So when we look at our character, here we go. Our character is a kinematic body, and it has a collision shape. There you go. And it's not a form-fitting collision shape. It doesn't need to be. It's just to find the location of our character. That's what we're using that guy for. We're not even using this to bump into things and stuff like that. We're just using it as a detector mechanism. But the other thing that's really important is that I've put my player into the friendly layer here. Now, when we look at my light, which is my torch over here. So this is my hanging torch that hangs off the building. There we go. A little light. This is an area node. And I call that area node player detect. So I'm not using these properties. This is if you actually want things inside of the area to react, to have different gravity and stuff like that. You can do a space override. I'm purely using this as a detector. So I've got monitoring turned on and monitorable turned on. I don't actually care about that one. I really only care about monitoring, because that is saying that, okay, I'm going to detect whenever physics bodies enter this area. And a kinematic body is a type of physics body. So whenever my mage gets in range of my area, and my area has got a collision shape, which is a sphere, so that's this sphere. Whenever my character enters the inside of this sphere, it is detected by this area. You can also see that I've got a mask on my area. I only want to detect physics objects that are in this layer. So our mage is in that layer. So this is the layer that we're in. That's the detection layer, which I don't care about in this case. I'm in the friendly layer. While if I, for instance, go and look at my enemies, and I don't have any enemies yet, but if I look at my base character here, I'm actually in my enemy layer. So my torches won't light up if an enemy character comes in. It only lights up if the player character gets inside of it. So when our player enters the area, our area detects that. And what our area does at this point in time, it sends out a body entered signal. So when my character enters the area, I get that signal, and I said, go and call that. When my player exits the area, so it moves far enough away, I call exited. And these two methods, all I'm doing is I'm increasing the player count, the number of players inside, because I could have all of my characters inside of that detection sphere. And then the count will be, let's say 4. Let's say that I'm controlling 4 characters in my party. And when they leave, I'm decreasing it. And only once the counter is back to 0, I know that there's no more characters inside of my area. So I'm just simply calling player count, in which I'm saying, if there's nobody in my area, I'm going to turn my light off. If there are characters in my area, and before there weren't, I'm going to turn the light on. If there's already someone in there and someone else enters, it's already enabled. I'm going to ignore it, but I still want to keep track of that counter. So that in a nutshell is how areas work. You define an area, you give it a collision shape, and then any physics body that enters or exits that area will trigger signals. They will also keep track of it. So there is methods on the area where you can say who's currently inside of that area, but then filtered based on the mask. Now, other things that you can do with areas is, for instance, you can change the audio system, and you can change, you can add an extra reverb on it. This is actually really, really cool because you can do, like, for instance, if I'm driving a car and I'm entering a tunnel, I could set up an area inside of that tunnel. The tunnel detects when my car enters the tunnel, and now it adds a reverb effect on the engine sounds. And suddenly you hear as if you're inside of a tunnel. So that's how you can use that stuff. And then obviously your space override, you can say, hey, if I'm inside of this area, I actually want my gravity to behave differently. So you can make like a Mario Galaxy kind of game, where if you're inside of the area of a planet, then your gravity pulls you towards the center of that planet, for instance, which is a pretty cool effect as well. Hi, Rodrigo. I hope you're doing well. All right, let's get back to implementing our character select logic. So we saw, oh, it's gone now, unfortunately. Oh, here you go. We saw that all our material files were found. We're going to just be checking our excuse me. We're going to go and check our material here. So we actually need to strip off we need to strip off the top part of this. So hold on. Let's go and have a look at string. No, let's actually first look at resource. No, it just returns a string. I think that we have. Okay, get file. And obviously file name is a reserved word, so let's go and change that. Does it turn blue? I never trust that. Now the other thing that I want to do here, and I'm happy enough to make that an export variable. Can I do it like this? I have no idea. Lights to okay. Export hint isn't a okay. Let's go. Let's see. String dir, that's what we need. I knew I had done that before. And let's go and select this folder. Perfect. Sweet. All right. All right, so let's go and say that. And let's see if that's correct or if we're now missing something. Okay, so that could be that because this is still open. No, we have that there. Okay. Okay. What are we looking for? That's empty. Okay, so why? I'm guessing because we have this guy open. Yeah, thought so. This is so annoying that sometimes Godot will not take our new properties into account when something was open at the time of editing. It's a bit annoying. Oh yeah, so we have a breakpoint there. So. All right, so as I was afraid, there is no slash there. Now, let's go back to our string, because I think even for this, there is... I thought there was like a function to actually add something to a path. But I'm happy to just do that because Godot always uses a / for that. So what we're now going to do is if... oh yeah. File exists. Here we go. Is that a static method? Or do I actually need to create a file object? I think I'm going to have to do this. It's a bit silly, but... let's put that in here because we're going to reuse that a couple times. There we go. And now we can say if file exists, file name. Let's actually call that... no, pretty good. All right. Let's be consistent. Bit overdone, but that's okay. Hi, Gills. How you going? All right, it's got about half an hour left. So now we have a file name. Very good. Now we can load our highlight. Actually, let's make a dictionary first. No, we can just put the material there. Okay. So this is going to be highlight material. Material is load. And that will load that material. If we loaded that successfully, we're going to do entry materials. We're going to do path. Are we going to do that, or are we going to do the active material here? I think we can, actually. we can use objects as our lookups. Alrighty. So now we should only get our purple material in here, and we should only get a printout of all the meshes that actually use our purple material. Our mage hat, our mage body, our arm left, I think that should be arm left, and our arm right. Okay. So, now what we're going to do is when our character becomes a current character, we can simply loop through our nodes here for highlight node in that. All right. Cool. There we go. Boom. So let's go and oh, we can actually, right? You know what? We're going to keep the name as the same. Mesh instance. In mesh instance nodes, we're going to loop through each of those. Then we're going to go. Oh, yeah. We actually need to get that from the node. Okay, that's wrong. So this is actually. Let's actually call it entry. And what we're going to do here is var mesh instance is entry node. There we go. Now we're going to loop through that. We're going to find our active material, and we're going to say if entry, what did we call it? Materials? I think there's a has key. Yep, has key. Active material. Then what we're going to do is we're going to say mesh instance set surface material. Let's go and make sure that we know that this is a mesh instance so that we get auto completion. We're going to replace it. All right. Now I want to run through that same loop in here. But here, what we're simply going to do is we're going to clear out our surface material. Now here, I'm not going to care whether there is a surface material or not, because we know that if there is one, we would have set it. Oh, it's null and small. All right. So let's see if our mage now ends up being highlighted. It is not. All right. Let's go put a breakpoint there and see if this wants to work. Okay. You're not going to tell me that this is called before this, right? It is. Okay, that's fine. Okay. Blank. Highlight. Capture. We're going to move that in here. Okay. is current. And false. There we go. And here we're simply going to say if. All right. So if we can't do it in time, we do it postponed. There we go. So our image is now nicely current. And now we can see that our image is no longer. Now, obviously, our good friend Knight doesn't work yet because we haven't given him anything yet. And now our image is current again. Cool. All right. Let's have a look at our Knight and do the same thing with our Knight and see if our Knight wants to work. One more time. Okay, cool. So our Knight has got a material, and I think we're going to use this one. So that's metal. Okay. Let's go back to here. So that's going to be 0.2. Specular is still 0.5. Roughness is now 0.3. And now we want to have the color. That's going to be that one. Okay. Oops. No, I don't want to save it. All right. So now we're going to go back to our purple material. And what I actually want to do is I'm going to actually save. I was afraid of that. I can make that unique first. So weird. Then I can save this in our shaders. And we're going to call that highlight shader trace. Okay. Yeah, that's all good. Perfect. And that means that we go to our Knight body and we create a new shader material. We should be able to load our highlight shader. And we make that nicely like that. And that was 0.4, I think. No, 0.2, 0.5. No, 0.3, 0.5. And then, okay. I think we're now doing that that color just fine. We actually need to do the normal gray as well. Okay. Let's go for that. And then where is that color? Let's go a little bit more this direction. Okay. So now we're going to save this here. And we're going to call that metal dot material. Okay. All right, let's go back to our Knight body and see what else. So I think we should have done this one, which is stone. Shader material. Yeah, now we got the body of this guy. So I'm going to go clear that because we don't need to do anything with you anymore. I'm happy enough to have more of the okay, we forgot to actually have a look at what our material should be. So let's go have a look at this guy and say that. Let's go over there. 0 and 0.5, 0.3. Okay. Copy those over. That was 0, 0.3, 0.5. There we go. And now let's go and make you a nice bright color. There we go. Sweet. All right, so this was called stone. Why Godot don't set materials from default? How do you mean? Well, how should it set it from default? How should it know what your default should be? Because, you know, we haven't defined any defaults. We haven't set any defaults on our values here. It's interesting actually that you can't set defaults on the uniforms in the visual shader, because you can set defaults when you do a normal shader. When you just write a shader from scratch, you can actually set defaults on there. All right, so let's clear this guy. There we go. And let's see if our thing works. All right, so now our night is nicely highlighted. There we go. Makes it a lot easier to see whose turn it is. I am pretty happy with that. Cool. Oh. Yeah, that's pretty neat. All right. It displays material, but in the materials section, there aren't any materials. I'm not quite sure if I follow you. Because our materials are here, and you can see that they are there. Or do you mean that these are empty? That's because it's taking the materials from the mesh. So we got a mesh here, and our mesh has got its default materials. If you don't have any materials set here, that means that you're not overriding materials. So it's using the materials on the mesh. Only if you want to override it, if you want to say don't use the material on the mesh, use something else, then you set a material here. It's not supposed to copy them over, because that means that if you change your mesh, all of a sudden you have to go through all the places that you've used your mesh and change it there as well. So empty means use the material from the underlying thing. And then you have actually got a material override in here. If we set this one, then it sets all materials. So you can see that now every material of this whole thing is set to that. So even if I change something here, it has no effect because I have overridden that material. So there's layers to the materials. Now if I clear this, now it's going to use that one. So you can see that that one is now used, but all the other ones are now going back to the defaults there. So it's a layered system. It looks at the override. If there's no material on the override, it looks at the material on the mesh instance. If there's no material on the mesh instance, it looks at the material defined on the mesh. That's how it's designed to work. So it's all about overriding the default. Alrighty. Task done. All right. I can't remember what that thing is anymore, so I guess we're not going to be able to do that. All right, so now we need to start looking at displaying our path. And that's going to be a little bit more tricky. And I'm not sure we're going to finish that in the last 20 minutes. So we'll just see if we can do at least some of it. But yeah. Ogres are like spatial materials. Okay, I'm not sure if I follow the reference, but sure. I like spatial materials, so they're cool. Okay, where's the main scene? Where's the main scene? So on our character script, we have the logic about doing our A star. And then we have a path. It's not empty. We can move. If we can't move, then we do that. Oh, they have layers. Okay. The ogres have layers. Maybe they're like onions then. All right. Cool. All right. Um. Oh, Shrek. Oh, I haven't seen that movie in ages. Yeah, I remember that scene now. Yeah, that was hilarious. Okay. So I'm going to be in a player character. Okay, so it's in a player character script. We can make use of that. So we need to have something that shows our path. Up to a maximum of 5. Okay. Ba-ba-dum-ba-dum. Oh, it's a little bit more than I wanted. Okay. So create something that allows us to show the path that we're walking. Okay. Okay. Now, luckily, that's already the right size, which is really cool. There we go. Perfect. Now, I do want that to be... Actually, I'm going to do that on my path. Let's do that at the end when we're actually positioned everything. Okay, so... I'm going to call this step. We're going to number them eventually. Okay. Actually means that I'm going to go and save this as a where is it? Characters. That's where I want it. Okay, so we're just going to call that step scene. All right. So now I can call this 0, 1, 2, 3, 4, 5 because we need 5 of them. All right. So we'll view a little further. View a little further. View a little further. View a little further. There we go. So we've got a maximum of 5 steps that we're going to be showing. Right. That also means that here we want to do visible is false. Here we're going to make it true, and then obviously we're going to do something in here. No, R 1. Four. No. We have wow? We do. I smaller than 5. Not smaller or equal than 5. We're going to do get get node step. I shouldn't have added 0 in there. I'm gonna take the 0 out because we only have 5. No, I just want to get the 0 out, not the whole thing. There we go. All right. Let's see, there we go. Visible is full, so we're going to hide those guys. I don't think I do anything in Mark anymore. Do I? I don't know. Let's have a quick look. Where's my cell script? What do we do in Mark? Oh, Mark was just the color stuff, but I've hidden those for now because I want to keep that code. Actually, that means that I want to go and put this at the end. Just for debugging. So I'll remove that eventually. Why am I not using the stable version of Godot? I've got a very simple reason for that. In our A-star logic, we are using a function called, where are you? Where am I using it? No, it's not here. Where is it then? Did I do it here? No. Maybe here? No. Somewhere in... somewhere in my code, I am using a function called append array to append 2 arrows together. And that was added in 3.2.4. That's the only reason I am using 3.2.4 at this point in time, because I want to use that function. If I currently run it on 3.2.3, it breaks. And seeing that I can't even remember where I'm using append array, I'm not even sure if it's still important. I might even have removed that logic already. Here? I don't know. I don't want to look for it now. Too much work. Any room? I don't know. Hey, Altazar, not today. We're not working on VR today. I do want to get back into doing a couple of things with VR, but at the moment I'm just having a lot of fun with my little dungeon game. Although there is a chance that we might eventually turn this into some sort of VR game. I don't know. Or give it a VR mode, like a third-person VR mode or something. Or maybe even a first-person VR mode. I don't know yet. I haven't decided yet. But I want to get back to my space game pretty soon. And there's another thing that I want to do, which is a smaller project. Just a demo project that I really want to build. I might end up doing that on stream. I'm not sure yet. But right now, I'm just having too much fun with this. And I completely lost what we were building. Where is my A-star code? So, all right. So in this case, we want to make this visible. we also want to go and... No, I don't want to make a global transform. Cell.global transform dot origin. Call that position. All right. Okay. Then we want to do pos dot y is step dot global transform dot origin dot. You know what? I'm gonna do that the other way around. Because I only want to copy the X and Z. I want to leave the Y alone, and that's something that I almost forgot. I want to move this a bit up. That's more than enough, because else we're going to have it sink into the other thing. All right. So that should be putting those all like that. Now I need to actually show something on these. So let's go and open this guy. We're going to go... No, we're going to go and do a material over here. Spatial material. I'm going to make this guy local to scene. And the reason that I want to do that is I want every step to have its own material. We're going to make this guy transparent. And we're going to keep that alone for now. There we go. This one needs to have a script as well. There we go. Export for now. Export. Texture. Bar. Texture. There we go. And here we're going to do step dot get. Oh, that's it. We don't have a step. Okay. Material. Is get service material 0. Material dot beta texture is texture. And actually I want to do a set get here. Set texture. Func set texture. There we go. So that is going to become null. New texture. Texture is pick. New texture. If material. Then we're going to go and do this. That texture. Texture. We're going to set it to itself. There we go. And now that becomes a tool script. So that becomes active while we're editing. Oh, that's cool, Altrazar. That is really cool. The more people doing VR with Godot, the better. So I'm glad you figured it out. And that you're on your way to building a VR game. Very good. Oh, I could probably do a global search, Gabriel. I just don't want to spend the time right now. It's not important enough. I just can't remember what I used the append array for. We can also start it up at 323 and we'll hit a breakpoint when it says, I don't know what this function is. Or if I did already remove it, then obviously it would work. All right. I need some textures. Do I have Krita in here? There. Nope. The other one. Okay. Needs to have a name. Where's Greedo? Here's Greedo. All right. New. 256 by 256. Don't care about the DPI. We want RGB alpha, 8-bit. And I don't care about the rest. There we go. We have... Okay. Now... I want the background to be transparent. How do I make... Here we go. No, can I? Here we go. Great. Perfect. Go away with you. There we go. We have a nice thing here. And what I want to create here is a circle. Is that going to work like this? Yes, it is. This doesn't help if you don't have a color set up. And I think probably that is not good. I'm just going to make it white. Why doesn't it not draw my circle? Oh. Yeah, not filled. I want an outlined brush. Size. Okay, I've got FX brushes turned on. That's not good. That's probably my problem. What about this? Hey, this is Alex. How you going? You guys can see how good my Krita skills are. Non-existent. Okay. I'm gonna create a new layer. What if I draw? That's why I couldn't draw in my background layer. Okay. All right. I actually want to make sure it's slightly smaller. Do I have coordinates somewhere? Why can't I see my coordinates? Can I turn it on somewhere? I want to see. Over 9,000. Not with Krita, man. I do not use this enough. I need some more. All right. Grid and guides, I think I need to add for what I want to do. Where did I just see grid and guides? Grid and guides. There we go. All right. Show grid. Perfect. I want to do that 10 by 10. Perfect. And let's go do snap to grid. So that should mean that it should nicely snap to that. And then, okay. So let's undo that again. We made this thing 256 by 256. So let's go and make sure that we're using a grid that fits. And the whole idea is I want to make sure that this is a perfect circle for what we're doing. I do want the circle to be bigger. And that means that I also probably need to go from there to there, or else it's going to fall off. That's good. I like that. Now, I don't know if white is the right color, but we just need to have a color. All right. So let's create another layer. So this is going to build our circle. And this is going to be called number 1. And now, this is the only thing that I really struggle with here. Can we go and just move that? No, we can't move that into a separate section. That sucks. This guy needs to be bigger. You know what? My grid is now set up. So let's hide it again. Now we have this one. I'm happy with red. Okay. 1. All right. What font are we going to use for this? Not Comic Sans. I'm not crazy. What is a cool font for something like this? Some sort of script. Oh yeah, there's plenty of places to get. I'm gonna go for Sogi script. It needs to be a whole bunch bigger. Let's see what that looks like. That's pretty cool. It just needs to be a whole lot bigger. All right, we're obviously gonna position that. Actually, I want this even bigger. I can't make it that big. What? Oh, I can. All right. Boom. Let's move it into place first. Oh, do I need to close that before I can do that? That sucks. There we go. Perfect. All right. I'm happy with it being red. I'm happy with it like that. Do I want to do anything else with it? No, I think I'm actually happy with this. So, oh, look at that. It's actually made that into another layer. Okay, so I can remove this guy. Boom. All right. Now, can I duplicate this layer? Is there a duplicate in here? Duplicate layer. Okay. You know what? I'm just going to call that 2. Vector layer 2. Perfect. Now we're going to remove that one. That's still selected. And we're going to change you to 2. All right. I don't really care that it is not perfectly centered. Or do I? Let's see. Let's move this up a little bit more. Okay. So the problem is, that means I now also need to move this guy up. There we go. All right, cool. Duplicate layer. Gonna be called 3. And guess what? We're gonna turn that into 3. Cool. Duplicate. Hide. That's gonna become 4. Next. You are going to become 4. And now we're going to make 5. Yeah, well, it is what it is. I'm wondering if I should move my circle to the top. There you go. So the circle goes over the 5. Should it be over or under? I don't know. All right. Anyway, let's go and first of all, save this. No, that's going to go to Documents, Godot, Dungeon, Acids, Mux, because that's mine. Numbers, Okay, so let's start with 1, and we're just going to say export. That's going to be called a PNG number 1. Save. All right. File, export. And that's going to be called number 2. Okay. File, export. And that's going to become number 3. File, export. Number 4. And last but not least, number 5. And actually, number 5 is going to be our end destination, so we might end up doing that differently. I don't know. Do you think the Guardian limits the performance of the quest? You mean as in rendering the Guardian over your view? I don't think so. You know, it's handled on the device itself as part of the composite layer. So I don't know if that would have a lot of effect. I don't know, to be honest. All right, there's a number 1. Do I want to change that to a non-shaded material? Let's assume that I don't want that shaded. That now needs to be reloaded for that to take effect. Okay. Is that our same problem as before? Yes, it is. There we go. And I bet you that this has the same thing as well. Okay, one of the things that I really should have done, you know what? One of the things that I am going to do to safeguard myself from that is I'm going to go and put a mesh instance here. Then I'm going to now copy this to here. Paste. Now I'm going to copy this to here. And now I'm going to change my type to spatial. And this way I have now isolated my mesh instance from my thing here. So that obviously means that I need to do mesh instance dot get surface material here, because we're going to change that from there. Now this still has a material that is local to scene, and that's the important bit. So now when I go into here, these guys should no longer have any of that. Okay, now the other thing that I need to change is that now needs to become spatial. There we go. And now I should be able to say number 1, number 2, number 3, number 4, number 5. Okay. 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 And of course. Oh. Why did that suddenly go? Ah! Ooh, what? Yeah. Dumb. This one. There we go. Okay. That also means that need to make sure that that is invisible, and that also needs to go invisible. There we go. All right, there we go. Haha. That's pretty cool. I think I need to move my camera a little further because I can't actually see how far I'm going. Can't actually get that far. All right, it's interesting. Let's go back to main. Camera rig. Nope, we need to go into our camera rig itself. Let's make that 20. All right, that's better. There we go. We can see how we're walking. Now, I'm not sure if I'm happy with this. I'm wondering if we should not have this smaller. I'm not sure. The other thing that I'm thinking about is that I might recreate this with just the numbers and actually have the circles part of the shader, because I want to make an effect there. But all right. Okay. Actually, a really nice way to solve that. I'm going to change the type here. Just a node. Oh, I can't make that invisible. Okay. Change the type. Node 2D. Oh. I have no idea. No, that doesn't trigger it. Oh, that's a shame. Okay, I can't do it that way. That's fine. Just being spatial then. Then what we're just going to do is when we start our move, we're also going to make our path invisible, because that's no longer plays a part. I'll have a look at software scanning in a second. Ooh. What's happening now? Oh, yep. Because we removed this, we lost the fact that this needed to be slightly above our floor. All right, now the other thing is, I actually don't want this to show up in our map, because we can see that the numbers are appearing in the map. The other thing that I want to do is, now I've used 3 action points and we get to do that. I actually want to make use of that. So okay. All right. What I'm going to do here is, wow, smaller or equal than minus p. All right. Hide spent points. There you go. Show our path. Actually, want to go and do that, and then all right, that's over. Let's see if we did that right. 5. So this all works. So let's go 1 further. So now we can see. All right, all the way to 3, 4, 5. So now we see the action points that are left instead of always counting from 1. All right. Now again, you know, these are just placeholder graphics anyway. One of the things that I want to do is, instead of having that green square, is have some sort of effect. And that's also one of the reasons why I'm thinking about removing the circle. Although the fact that we now have a path, we could also make that part of our path thingy. I'm not sure yet. But yeah, I think it is pretty cool how this is now working. Alrighty. Software skinning. Where did you see the software skinning option? Oh, that one. Okay. This has to do with when you have an armature, when you have bones. So if you have like a character, like when we're looking at our mage, where's our mage? Currently, this animation works with solids, right? These are just all meshes. And our animation, when we play an animation in here, we're actually repositioning all the nodes. We're not changing the mesh itself. But what we could also do is we could have a single mesh that is the whole character. And we can use the bones, and we can actually see our bones here, but we can actually use our bones to deform the mesh and make the mesh move that way. And the nice thing about that is, especially with high detailed meshes, is that you can get really nice smooth deformations, you know, especially for a character. You know, we're not made of fixed things, right? When we move our arm, you know, that's not, you know, like two bricks moving or two sticks or whatever. It's skin deforms and everything like that. Which is also why that's got a skin and then a skeleton, you know, next to the mesh. That contains all the information about how the mesh deforms. Now in Godot 4, and I think some of that was backported to Godot 3.2.4 as well. That deformation now fully happens on the GPU. So as the bones animate, the information is added to the data sent to the renderer. And then in the vertex shader, we are deforming the position of the vertexes based on our skeleton. However, that is not supported on hardware. So on hardware where that is not supported, we go back to a software version of that, which you can turn on in your projects somewhere. And I haven't really looked at this before, so I'm not sure where it is. Oh, okay. Oh, that's pretty cool. That's all physics. Okay, I'm looking in the wrong place. So is that somewhere over here? Here we go. So we got our software skinning fallback on, but we can even force the software skinning. So, and I think on Glass 2, it's always software skinning. I'm not sure. Might be that on Glass 2 you have to have software skinning. I'm not sure. But yeah, you can fall back on that, and then we do the mesh deformation in the CPU side, which does mean a whole bunch more stuff being sent to the GPU every time that you render a frame, so it's a lot slower, especially for high detailed meshes. Now, I guess this is just the option that you can say whether you want your normals to be adjusted or not. Because obviously, as your arm moves, you want the normals on the surface to change to have the lighting correct. But it can be that can take its toll when you do software skinning, because you don't just update your vertex buffer, you also update your normal buffer. So that's the option that we have there. So that really only matters if you have the whole deformation stuff done. All right. Well, we have that solved. And, well, the first version at least, right? There's a whole bunch of polish that we're going to be doing as we progress with this game. But I think as far as the basic logic is concerned, that does exactly what we want to do. We can nicely see the path that our character is going to take to move from its current position to where we're pointing. Perfect. Alrighty. That is pretty cool. Okay. Sweet. That's pretty cool. So we've got our highlights solved, and we've done it in a way that we, now obviously, and actually I'm going to add that to the off screen, is make more highlight versions of materials. And again, I don't know how far I'm going to take that, but at least we have some of that. Well, I don't remember what this is, so I am going to just archive that. All right, pretty cool. Let's go and do that one next stream. And I want to spawn some enemies. I think that's our... Zahil, you're right. We still need to do the skip move. Actually, have I got that in here yet? So I think that is actually a good one. Do here, skip move. And then indeed, you know, we're going to have our attack phase and our end turn logic in there. Because right now, we have to make 5 moves before we can attack. Now, here lies an interesting question. When you look at like a typical Dungeons and Dragons game, I shouldn't say that too out loud because I'm not trying to invade on Dungeons and Dragons copyright, because those guys are kind of aggressive when it comes to that sort of stuff. But what you have in those sort of games is a split between the type of action points that you do for moves, so your move points basically, and in that way I'm wondering if I haven't named my action points incorrectly, and your actual attack points, so how many points you can attack with. And the way it kind of works with those games is you just do one attack, right? Or you have yeah, I think you can do one attack, but then you have a strength with which you attack. So you got a base strength, and then you have some random modifier on that. You might have increases in strength based on abilities or things that you picked up. You know, if you have a +2 Vorpal sword, you get +2 extra attack points. And then, you know, your base attack points plus your extra attack points plus, you know, your roll of the dice attack points. If that number is higher than the damage points of your enemy, then you destroy the enemy. And if it's lower, then basically your attack fails. So that's one way that we can do it. Now, the other way that we could do it is looking at games like Fallout, like the original Fallout, right? Which, by the way, with what we've built right now, we could make a Fallout clone if we decide to go down that path. Which I'm, you know, wouldn't even be against. I'm a big Fallout fan. So, especially when you look at the original Fallout 1 and 2, you know, the turn-based Fallout games, you could build something like that with this. something inspired by that. So there you just have action points, and you can use those action points for movement, and you can use those action points for attack. And there it is, the weapon that you're using, or the type of attack that you're using, that depends on, or that defines, or that have a cost to it. So let's say that you have 5 action points in total, so we can make 5 moves. But a sword attack costs you 2 action points. So as long as we stay within 3 moves, we can then still do an attack with our sword. If we are already next to our enemy with 5 points, we could do 2 attacks with our sword and then still have 1 action point left over. And then the attack itself then becomes successful based on the strength of your character, the strength of your weapon, and some random thing. And if that then scores high enough, your attack is successful, and then it does whatever damage the weapon does. That's the other thing that's really interesting, is that your damage count is then dependent on what it is that you do. And then you just chip away at the health points until your enemy goes to 0 health, and then your enemy dies. That's actually with the Dungeons and Dragons approach as well, is that if you have a successful attack, your weapon or whatever ability that your character has does a certain number of damage. If that number is equal or higher than the HP of the the enemy you attack, the enemy dies. And if not, their HP just gets lowered by that amount. And then obviously, they can heal and stuff like that. Yeah, Zahil, indeed. That's probably why they did it. That they said, we're going to split that, because you go through these turn phases. Because also you get, discussions like, can you move and then attack and then move again and attack again? That sort of thing. And a game like Fallout said, sure, as long as you don't run out of action points. Now, that does mean that I'm likely, if we do go down that path, is that I'm going to need more than 5 numbers to use, because I'm pretty sure that we, especially when characters level up, we might eventually get up to 10 action points. And that's the only thing that I don't like about that approach, is in order to have some serious movement, some serious attack power, I should say, you automatically get some serious movement, right? So let's say that you want to have a weapon that takes 5 action points to use. Well, unless you want to make sure that you can only use that weapon if the character is already in the right cell. Yeah. So yeah, there is a part of me that is wondering whether we remove this turn state altogether, and we just say you just have a number of action points that you have to spend. If you spend them, it's the next character's turn. If you don't spend them, you have the option to say, I'm not going to use them this turn. I'm just going to skip over to the next turn. And then, we might do something that you can use your leftover, or you can use half of your leftover or something like that in your next turn or something like that. That wouldn't be a bad mechanism either. You can save them up. The other thing, of course, which is really important in many of these games, is if you expend your turn with action points left over, those are the action points that you can use for defense when you get attacked. So you get a defense bonus. If you use all your action points, you should still be able to defend yourself. But you might be at a disadvantage, or maybe if you have action points left, if you get attacked, you get a parry or something like that, right? There's just an extra layer that you can put to it. And that could also be, the name of the end. It's not your end your turn, it's, go to defense mode or something like that. So yeah, that is something to figure out still. All right, guys. I think that's where I'm gonna leave it tonight. We've done the two things that I set out to do. It's past 12. It's 12:30 already. Yeah. I think that was a good bit of extra stuff that we did. So yeah, thank you all for watching. No, the LOD is not functional in 3.2.4. That is coming back in Godot 4. Not sure if we're going to retrofit something in Godot 3.2.4, but LOD is currently not functional. So no, the LOD settings don't do anything. Alrighty, thanks you all for watching. I hope you guys will join me again next Friday. I am already working on the video for the dungeon generation, so obviously we've got that all working. But I'm gonna do that in a review form, so I'm doing some nice little animations and stuff like that. So I hope to have time for that in the weekend and see how far I can get with that in the weekend. But I do hope to have that tutorial out soon, because we're also starting to get ahead of it a little bit on this. And that might be actually a good reason to, at some point, pause the dungeon game for a couple of streams so that I can catch up with the tutorial and you know, do a few other things on stream. Either get back to the space game or, you know, do the demo, the VR demo that I want to do. I just want to make a very simple one level VR game using all the boilerplate stuff that we've already built. I think that's something that we can do in 2 or 3 streams just to get that knocked off. So that might be a nice thing to do. I'm not sure yet. Having too much fun with the dungeon game. All right, guys. Thank you all for watching, and like I said, I hope you guys will join me again next Friday. So till then, bye.